Okay, the next one. What's the difference between R2 and R4? A radius smaller than R. Okay, so now I'm going to go inside the sphere. So I'm going to R4 here. This is R1, and we're starting at R2. So now things get tricky. Why are things tricky? Once I go inside the sphere, what is my electric field? It goes to 0 instantly. If it goes to 0 instantly, that means that as I'm crossing this line, suddenly from here to here, how much work is done? From here to here, I'm not doing anything, right? So I'm going to have to do two separate integrals because they have two separate functions, right? On the second part, though, so this is going to be R2 to, where am I going? R1. And I'm going to do the electric field just like we did. For the second part, I'm going to go from R1 to R4, right, which is inside the sphere. But what's the electric field inside there? 0. So what happens to this whole part of the equation? That's going to be 0, right? Because again, we're not doing any work there. So the only part of the work would be getting it from R2 to the top of the sphere. Yes, sir?
How do you know when you're going to need to use integral voltage or when you can do like field?
Does one depend on the other?
Okay.
If one depends on the other, you have to integrate. If one does not depend on the other, you don't. That's what it boils down to in this class. Okay? If you're multiplying two things together, one of them has the other variable in it, then you're stuck. You have to integrate. If they don't, then you're going to go the other route. Okay? All right, so moving forward, I've got the electric field, the same equation as last time. The whole thing's exactly the same. So my voltage would be, what was it? You're messing with me. I need a 4 pi E dot. What's the rest of it? Q on top, and then it would be R2 on the bottom?
No, it's R1.
R1 minus, there we go, thank you. I'm not going anywhere fast. I need my equation. Good. And then I check that one. R1 is smaller. No, yeah, R1 is smaller. So therefore, this is going to be bigger. The whole thing's going to be bigger than this one, which means it's positive. Would it take positive work to walk from here to that spot there? It would. So therefore, this is the correct answer. Okay, or the correct sign at least.
For 4 though, since you're both, I guess I'm needing to do 4.
Yes. So 4. Let's do 4. What's 4?
0.
0. I can wander around as much as I want to in here. I'm not changing my voltage, right? Because there's no electric field.
Run some a marathon inside the.
Takes no work to do it. At least no electric work. I'm not talking about gravity or anything else. Make sense?
Yes.
That's good Gauss right there. Yes, sir. Okay, so on this one here, I'm starting at R2 and going to the surface R1, right?
Yeah.
So I look at this and go, okay, so if this is a positive test charge, we assume a positive test charge for deciding what voltage is doing. So if I'm walking this way, would it require work or not work to put an electric positive? Require work. So this better be a positive answer when I'm done. If it's not, change the signs. I mean, check your work, maybe, but definitely change your signs. Okay? So I did look at this and I go, okay, well, R1 is smaller than R2, right? It's a smaller radius, smaller number.
Why does R1 come first?
R2, we started R2 and we went to R1.
Oh, yeah, that's what.
Is that it?
Yeah.
Okay. By the way, if you'd done it the other way and then realized the sign was wrong, you made that, if you had R2 in front or change the two signs, yeah, the right answer. That's why I say, if the sign doesn't work, just change signs. Right? Because you assume the problem backwards. Now, again, you'd have to then be thinking the particles moving from R2 to R1. Does that make sense?
Yeah.
And so you'd have to catch that part of it. As long as you catch that part of it, in fact, you did the integral backwards. You know, it should go from where you start to where you finish. The fact that you did it backwards isn't going to hurt you at all because you changed the signs. And again, as physicists, you're like, that's great. Don't do that in your calculus test.
Really?
Please don't do your calculus test. We'll never know why you lost those points. We'll have no idea. Got the right answer, but I got no points. Peter, good? Ready to do some Gauss quiz?
Sure.
Yeah. Does everybody have a formula sheet? Because I messed up and didn't make one again. I don't know why. At least I assume I didn't. I should go look.
Taking a quiz?
Yeah.